Hello, I'm going to demo to you building a MiNiFi C++ data flow using Edge Flow Manager, also known as Cloudera Edge Management, and then publish that data flow to our MiNiFi C++ agent on our EC2 instance. We'll be making use of our custom Python processors for ExecuteDaiMojoScoringPipeline and also the convert DS to CSV. So we'll start by dragging our first processor onto the canvas. It'll be a Git file processor for pulling in hydraulic system data. And we can also reference this documentation here that I wrote up for the path to our input directory, our input data. Double click the processor here, scroll down, we'll modify the input directory. And there's our input data, where it's located, and we'll set this to true for keep source file. Apply. We'll add our second processor. In this case, we're going to be adding the ExecuteDaiMojoScoringPipeline. We'll connect Git file to it on relationship success. Double click. Alright, and then we're going to add the path to our MOJO pipeline. And so it's right here. This is on our EC2 instance. So here's the path to our python.mojo. We click apply. That's all this processor needs in order to execute the MOJO scoring pipeline. Alright, next we're going to add on the convert DS to CSV. So this one, click add, we'll connect our ExecuteDaiMojoScoringPipeline processor on relationship success to convert DS to CSV. So what will happen is this processor, ExecuteDaiMojoScoringPipeline, will receive hydraulic system data. It will perform predictions on it and output hydraulic cooling condition for the results, and then that'll go through on relationship success to convert DS to CSV, and it'll convert the data source format of those predictions to a CSV format, and then we'll just add a log attribute processor to log info. So we'll make the connection on relationship success, and log level we'll set that as info. Okay, apply. And now we're going to add update attribute. Connect log attribute to update attribute, also on success relationship. For this one, update attribute will add a custom property file name, and what's going to be included there is going to be hydraulic real-time scores, the UID for a unique identifier. This is to ensure that each file has a unique file name as they get stored onto the local file system. We apply, and we'll drag and drop our final processor, which will be a file processor for storing the predictions to the local file system. One more modification to happen on update attribute, we'll set automatically terminate relationships on failure. Apply, and we'll make the connection update attribute to put file for relationship success. And now we'll auto terminate on failure and success relationships, and we're going to set the conflict resolution strategy to replace, and then our output directory is going to be this particular one with the last folder as predict real-time data. We'll apply. Now we're ready to publish our data flow to our MiNiFi C++ agent. So we'll click Actions, Publish. We'll write a description for this data flow. Executes Driverless AI and MOJO scoring pipeline within MiNiFi C++ data flow using execute DAI MOJO scoring pipeline. Processor and our MOJO 2 Python runtime API. Say our processor uses. So we publish. Now we can go to our terminal. We can check for where the results are being stored. We're currently in the EC2 shell as a root user, and so we'll just go to this particular directory. This is where the predictions are being stored. Here we can see our predictions are being stored. So we'll just click on one of these files. We'll also cd into that directory. And then we'll just run a cat on it to put it to standard out. And we can see here our prediction headers, cool condition 3, 20, 100, and then the results or the probabilities, 0.40, 0.21, 0.38. So from these we can see that the highest value, 0.40, is telling us our hydraulic cooler is most likely operating at close to total failure. If it was 20, then it would mean that the hydraulic cooler is operating at reduced efficiency. If it was 100, it would mean the hydraulic cooler is operating at full efficiency. But in this case, the highest value tells us that it's operating at close to total failure.